Okay. Hi guys. So welcome to Introduction to Python. I'm Reina and with me is Zechin and we'll be presenting for this workshop. So here's the agenda for today. So we're going through what is Python, how to use Google Collaboratory, then I'll be going through data structures and operators, whereas Zechin will be going through conditionals, basic iterations, and libraries. So firstly, what is Python? So Python is a general purpose interpreted coding language focused on readability. But what is interpretation? What it means is that it directly executes code line by line without the need for compiling. So it's simpler to run and it's a lot more readable. However, it's much slower compared to other languages. So if you look on the example on the right, line 1 tells Python that this variable text stores the value of hello world, and line 3 tells it to print it out. However, if you decide to put the declaration of text below the print function, it will throw you an error because it reads line by line. So it read print text first before it even knows what text is. So where can Python be used? There is actually a wide range of libraries provided within Python. So it means that it can basically be used anywhere. So it can go from data analysis all the way down to game development and web development. So for the sake of March conference, we'll be mainly going through data analysis libraries such as pandas, numpy, and matplotlib in the later workshops. So why are we using Python? So Python is actually a lot more easier to pick up compared to other languages. It's easy to set up and run, fast enough for most workflows, and has a large library ecosystem. There is actually no need to install Python locally on your computer. You can run it on the web through Google Colab. And the many different libraries let it be used for many different things with ease. So using Google Colab. So please if you haven't, access the Google Colab file for today's workshop. Then save a copy to Drive so you can edit it on your own side. I'll be here for a while.
If you have any question, you can just drop in the Discord channel under Intro to Python questions so that we know we can help you. Yeah.
Okay, moving on. I'll get started on variables and types. So variables are objects that store data, which can be changed later on. So here's how you create a variable in Python. First, you should have some examples of variable names in your Google Colab file. But the rules for naming a variable is really simple. So you just must start with a letter or underscore. Variables are case sensitive and must be a single word. So some words are actually reserved and cannot be used for naming variables, such as and true here. You can see, throws an error here. Because these have their own meaning within Python already, and so you can't reassign it. So here's how you receive input from the user. So use the input function, and you can actually customize the text that that the user will see using just by adding quotation marks and your text inside the input function. So when you receive something from the input function, it will be in the string data structure. So you will have to convert it using the other functions if for later use cases. So here you use the print function to output. You use print and whatever you want to output here. So here are the basic types that I'll be going through today. So we have integers and floats, booleans, strings, and lists and dictionaries. So strings, lists, and dictionaries are also under the category of iterables, meaning they can be used in loops. So it will be covered later. So firstly, integers and floats. So they're basically whole numbers and decimals. So 1 is an integer and 1.5 is float. So here we have two variables. num1 equals to 2 and num2 equals 2.8. So num1 is an integer and num2 is a float. We can actually convert them between the two types. So we can convert the integer num1 to a float, meaning new num1 equals to float num1. Same thing with num2. So you see here that new num1 is now a float because it has a decimal point here, whereas new num2 is now an integer. So the float function, the int function actually truncates the decimal portion of a float. So basically it rounds it down. So here's a quick exercise for you. Take roughly a minute. What is this variables type over here? So if you guys would just answer inside the poll. With like 10 more seconds. All right. Good to see that at least most of you are paying attention. So this is a float. It's a type float because of the decimal point here. So anything with a decimal point in it is actually considered a float by Python. Yep. So here are some basic operations for integers and floats. So you have your usual math operators: addition, subtraction, division, and multiplication. Then you have some special ones, such as floor division, exponentiation, and modulo. So modulo is actually quite useful for several applications, such as finding out whether something is divisible by a number, because it actually returns to you the whole number remainder of a division. So it can also help to tell you whether a number is even or not. So you can help to avoid this. So you can replace all these nested else if conditionals using a modulo function. So here's a short task for you to work on your own notebook. So play around with the modulo and practice your own input and output handling. So try taking the input of two numbers from the user and print out the remainder from the division. So I'll give you around 5 minutes. All right. So you guys can mess around the modules function, see what you can observe. If you do have some knowledge of Python already, you do feel free to read ahead first, or even attempt some of the tasks at the bottom of the notebook. Remember that if you have any questions, do feel free to message inside the Discord channel. Yep. Alright, guys. So here's how I would program this for this task. So here's a short program. You have num1 equals to int, input the first number, same thing for num2, and we just print out the remainder of the two numbers. Very simple. So sometimes there's something weird that can happen with floats. We have 0.1 plus 0.2. So it doesn't actually equal 0.3 here. There's 0.3 with a bunch of repeating zeros and 4. So 0.1 plus 0.2 in Python is not exactly equal to 0.3. So output you false. So this is due to the caveats of floating point arithmetic. So if you do want to, you can read up more on IEEE 754. And the main takeaway is that it isn't recommended to compare floats to one another, because you may have cases like this. Or this can happen. Don't be the guy that causes this. So I'll quickly move on to booleans. The booleans are true and false. They're usually the return value of other stuff like functions or comparisons. And other data types can actually be easily converted into true or false using implicit conversion. So any empty string, 0, none, or empty container is converted to false. And then mostly everything else is converted to true. And it's super useful for conditionals, which are covered later on. You can convert true and you can use the not keyword to change bools between true and false. So if not bool, this bool and the empty list here, which is the 2 square brackets, will actually give you a false. But not false will convert it to true, and so that's what you have printed out here. The true and false can also be converted into integers implicitly, where true is equals to 1 and false is equals to 0. Moving on to strings. So in order to declare strings, they're enclosed by quotation marks. So it can be single quotations or double quotations. So these two can actually be mixed to give different results. And the order and types of quotes matter. Otherwise, you can get undesirable behavior, such as errors. So here are some simple string operations. So you can append strings together using the plus operator and find the length of a string using this len function. So len string. So you have A, B, C, D, E, F, which is 6 characters. There are some special characters you may want to use in your string. So you can use the backslash, the backslash n for a new line, and backslash t for a tab. So here we have an example. The apple backslash n banana. That will be a new line between the two outputs, the two words, and backslash t for a tab. However, you may want to use backslash as a character itself, or if you have to, mix both single quotations and double quotations in a string, such as for a paragraph. So in that case, prefixing these characters with another backslash will cause it to be taken as a normal character in the string. So over here you can see we have 4 double quotations here, and I want these two specifically to be outputted as a part of the string. So I prefix each double quotation with a backslash, and it functions normally. Same thing with this one. I may want to use this backslash here. So I prefix with another one. We have chopped. So there are 2 subtypes to a string. It can be either prefixed with R or F. So R will give you a raw string. So backslash is no longer considered a special character. So you can't use backslash n, backslash t for new lines or tabs. And we have F for formatted strings, which are useful for outputting debug messages, because they allow you to make your string a lot more readable and actually know where what it will look like when you output it. So for example here, we have the formatted string of variable apple, where variable is the number of apples. So we have one apple. So moving on to lists, this may be getting a bit more confusing. So we declare lists using square brackets and separate the different elements within a list with commas. So lists are a dynamic container and can store multiple values of different types, even other lists at once. So here we have a list named X with different types of elements here. We have 4 strings and 1 boolean here. So lists are zero index, meaning the first element of a list is labeled as element 0, instead of element 1 as you would normally label items. So you can access an item in a list like this, where you have the list, open square bracket, the index, and close square bracket. So you can access items from the back of the list using the negative notation, with the last element being -1, -2, -3, all the way to the front. Remember how I said you could have another list within a list? So here is one application where you have a matrix. So here in this example is a 2D matrix. And if I want to access the third item in the second list, so this, I can access it like this. So I have X square bracket 1, square bracket 2. So you can visualize it like this, with X square bracket 1 to access the second list, and square bracket 2 to access the third item in the list. So you can read this. So you can read this operation as a whole from left to right. So here are some basic list operations. So you can change an element at a specific index by referencing the index of the element to replace. So it's simply list square bracket index equals to your new value. As you can see here. So I replace the first element, I, over here to 2025. Next, we have list slicing. So it allows you to access multiple elements at once. So here's the syntax for it. We have square bracket, the start index, the stop index, and the step. So the start index is inclusive. So the element at your start index will be included in the slice. So, and then the stop index is exclusive. So the item at your stop index will not be included in the slice. So it may be a bit confusing. But here's an example. So if I want to take the list slice from index 2 to index 4, it will actually only access items with index 2 and 3, and it won't include the item at index 4. So there will be some examples in your Colab notebook. So if you want, you can run them, test it out, and hopefully better understand list slicing. So if you exclude the start or stop value, it will be assumed to be the first or last item respectively. Yep. So here's a simple task for you to sort of better understand lists. So you just take a minute to try predicting the output of the code and run it in your own Colab notebook. Stay over here for a minute. All right, moving on. Here are some functions you can use on the list. So remember this from strings. So it basically does the same thing and tells you the length of the list. So how many elements are there in the list? So here's an example. And we have 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So len list will give us 10. And you can find the maximum value in the list using the max function. So it gives us 19. Yeah. So here's a bit more harder to read, but we have list methods. So you call methods using dot list name dot method, and you have the your parentheses. So here are the main functions that you may be using. We have dot append, which adds an item to the end of the list, the new item. We have dot pop, and here's the argument index that you have to put in. So it removes an item at a specific index. Then we have dot sort, which sorts the list in place. Dot copy, which creates a separate copy. Dot insert, where you want to insert an item at a specific index. Sorry, this is wrong. And we have dot index, which returns the index of the first matching item. Is this value that you pass in through here. So what it means by sorting the list in place is that it modifies the value of x itself rather than having you assign it again. So you don't need x equals x dot sort. You can just type in here, as you can see here, x dot sort. So dot copy is actually especially important for lists because of how Python handles copying lists itself. So let's say you have an example list here, y equals to this list of numbers. Then you want to make a copy z. So you set z equals to y. But z actually isn't a copy of y. Changing z will also affect y. So in order to create an actual copy, you have to use y.copy. So that now when you change an element of z, let's say you remove the last element 6, it won't affect y as well. So this is super useful for iterations, such as using a for loop, and as you modify the list itself. So it's best practice to always use the .copy version of the list when you are using it in a for loop, which Justin will cover later. So here are some simple use cases of a list: keeping track of column values in a spreadsheet, or keeping track of video game projectiles created in real time. So it's dynamically sized. You can add or remove items as you need to. So moving on to dictionaries. So dictionaries are declared using your curly braces right here, and they contain unique key colon value pairs. These separate them using the colon here. So you have keys on the left and values on the right. So each pair is separated by a comma like in a list, and the keys and values can actually be of any data type. So you see here we have an integer, a string. As for the value, we have a boolean for the key, string for the value. You can actually mix it all up. Right. So here are some basic dictionary operations. So we have dict square bracket key and dict.get key. So what is the difference between these two? So dict.get key is actually preferred for accessing values, for purely accessing values, because dict square bracket key will actually create a new key value pair if there is no entries with the specified key. So if you make any spelling mistakes when accessing the key's value itself, it will just create a new value and not throw you an error. So you may not know what's going wrong. However, if you do want to change a value within the dictionary, you will have to use the square brackets. The dict square bracket key will let you assign a new value to that key. You can also convert dictionaries to lists using the list function. Here are some methods for dictionaries. You have .keys, which returns a list of keys. .values for values. .items, which will give you the key value pairs themselves within a list, within a special kind of list called a tuple. And then we have .pop, which helps you remove a pair with the specified key. And you have .copy, which is the same thing for lists. So here are some use cases of dictionaries. So they are mainly used to increase readability and keep track of certain attributes dynamically. So let's say instead of keeping track of the number of items, number of letters that appear within a list, you can keep it track in a dictionary. So you can assign each letter to a specific value as they appear. So it can also be used to store reference data such as links or file paths, as you can see on this side. And some libraries use dictionaries as arguments for their special functions. So what you put into a function. So here's a short practice task for you to experiment with lists. So as mentioned before, dictionaries can be used to keep track of attributes of an object. And I'll give you around 5 minutes for this project as well. It should be really short. Okay. So I'll be going through the answers for this practice task. So here's how I will implement it. So I will have a dictionary for each person, the name here, with the name as the dictionary name. All right. So we have gender, age, occupation, and medical history as the keys, because they were the column names for the Excel sheet. Then we have each specific value for each person. Then for B, we modify his occupation, change it to content creator as needed here. So using the square brackets. So Michael square brackets occupation goes to content creator. Then we remove the medical history for each person. So in this case for Michael, we have michael.pop medical history, which removes this here. So here now we'll have a short break or Q&A session. So I'll turn on the Q&A function.
I
Yep.
done already. Yeah. So do put in any questions you have or like to clarify anything, then we'll answer them. We'll start answering at 10:40. Yeah, then in the meantime you can have a break. Yeah.
Hi, okay. I'll start by going through the questions. So for first question, syntax error, right? So you may want to check whether your previous key value pair, whether it ended with a comma, because it's a quite common error. Otherwise, it should work fine. You can use a string for the key and a none type for the value. It shouldn't really throw you an error. Also make sure you're using the correct type of braces. It should be curly braces for a dictionary.
If you tried everything Rainer said just now, but it didn't work, you can take a screenshot of your code and then you put it in the Discord channel so that we can better understand what's your problem. Okay? Yeah.
Then next up, benefits and key features of Python. Okay, mainly it's the user friendliness of Python because let's say you're a data analyst or some business exec and you want to take up programming to maybe level up your job. So Python's the ease of learning Python is a key appeal to them compared to languages like Java, where it's much lower level and the syntax may be more confusing for them. And try the codes out. You should be using the resources the Google Colab provided. It should be under March workshop resources in the intro to Python resources. So you create a copy of the Colab file in your own drive, and then you can work on it there. You can run it there. Yep.
If you still face problem trying to get the Colab file, you can also just type in a channel so like someone can assist you. Raina, you might want to answer that question.
Yeah.
Under assess the latest one.
Second. Something I should expect. Keys for dictionaries. Is that in the Colab file or on the sites? The Colab file. Check.
While Raina is checking, I will answer the sort question. So the sort function, right? The default is ascending. If you want to sort the other way, you can use there's actually a lot of functions to sort another, not functions, sorry, a lot of ways to sort the other way. Essentially you can use dot reverse or you can use Python slicing. Yeah. Right. Good question. Good question.
X1 output false. I'm not sure actually, but you can. But the reason why x square bracket 2 outputs apple is because 2 is a key within the dictionary itself. X square bracket 1 output may be false because right, okay, I understand now. Because true can be implicitly converted to the value of 1, right? So x square bracket 1 is the same thing as x square bracket 2. True, sorry. X square bracket true, which is a key in the dictionary and has the value of false. So it prints out false. So for the Google Colab file, right? You can go to on the Google Colab file right now. So you can go to the top left, click on file, and then after that you find the option save a copy in drive and open it there. Yeah. Then you can access the Colab file yourself and test out the exercises or play around with what we are going through during the workshop. Okay, if that's all the questions, then the thing can continue with conditionals.
Gunev, I'm not sure. Sorry if I mispronounce your name. You found a Google Colab, but you don't know how to do from there. So you can make a copy for yourself. You click on file, then you click on save a copy in drive so that you can edit. Then you can just try to follow what we say, and then like if there's like questions that you that we ask you to do, you can just code from there. Yep. Okay, so let me turn off Q&A. Okay. So now we'll be continuing with conditionals. So basically what conditionals are is that it's a statement that allow code to execute different actions based on whether a specified condition evaluates to true or false. Essentially, it uses a boolean, okay? It may sound confusing, but yeah, let's see what it is from now. So before we cover conditionals, right, let's see what are mathematical conditions in Python. So essentially there are 6. For Python, equals, we use double equal sign instead of 1, because for 1 means that we're assigning a value to a variable, okay? So for not equals, we use an exclamation mark and the equal sign. Then for greater than, it's the same as what we learn in math, so on and so forth. Okay. So let's see this question. Okay. So given 3 variables, x, y, and z. So x has a variable apple, which is a string. Y has the variable, y has a value of orange. Then z has a value of grape. So, okay. So given this function len, which Rainer covered just now, just a quick recap. This is to find the number of characters inside a string. Okay. So if we see, we can find that len of the variable x is equal to the length of the variable z. So how do we show it in Python to let the computer understand? Is that we use the equal sign. Then for the length x, because it's not equal to the length of y, so we use an exclamation mark and an equal sign. Yeah, okay. So now officially starting our conditionals. So the first thing we'll be studying is the if statements. So if something is true, what is going to happen? So the basic formula is here. So if a condition, which we need to specify, then we ask the computer to do a certain action. So if you notice, right, before this action, there is a space here. So it's called indentation. So essentially, it tells the computer that, hey, this action code, right, lies within the block of code, like the if statement. Okay, so it tells that they are essentially they are connected together. Okay, so let's see this example here. So let's say x equals to 5 and y equals to 2. So if 5x is more than y, so 5 is more than 2, which is correct. So you'll print x is greater than y. So yeah, it's correct, because 5 is greater than 2. Yeah, okay. So what about the other conditions that we do not want to specify? We'll use the else statement. So if is if something happens, then else means that everything else, okay? So if a certain condition is fulfilled, then the computer will do a certain action. Else, if the condition is not fulfilled, we'll just put a certain action. So why, you might be asking, why not we just put if condition, if not condition? But you know, in Python, right, in the coding world, we try to make everything concise and easy to read, so that the reader or like the other coders, they can have an easier time to study what you're trying to say. So we just use else. So you see this example here, we are trying to find odd and even. Okay, so we have the same variable x and y. So if x mod 2, recall that the percentage sign means modulus, or we can call it mod, is used to find the remainder of when something is divided by another integer. Okay, so if x mod 2 equals to 1s means that when x is divided by 2, the remainder is 1, print odd. Yes, this is correct because we know that when something divided by 2 has a remainder of 1 means that it's odd number. Okay, everything else, print even. So why do we put else instead of if x mod 2 equals to 0? Because there's only 2 conditions that can be met here. So like, let's just try to save time and just use else, okay? Yeah. So what if you want to try more conditions other than one condition and the else, but you have more conditions to fulfill? We can use the else-if statement. Else-if essentially means it's a short form for else if. So if the previous condition was not true, then try this condition instead. So let's see the code here. If a condition is fulfilled, print this action. Else, if this other condition is fulfilled, then print this action. So maybe it's kind of confusing. So let's see the example here. So this example here, we're trying to find we're trying to determine whether a number is positive, negative, or 0. So there's 3 conditions here. So we cannot only use if and else because in that case, only 2 conditions can be evaluated. So to evaluate 3 conditions or more, we use the else if. So let's see, we have x and y again. Then z is x plus y, which we know, quick math, is 7. So if z equals to 0, print z is 0. But we know that 7 is not 0, right? So we try the other condition instead. So else if z more than 0, print z is positive, which is correct because 7 is more than 0. So it should print z is positive, which is true because the computer output the statement z is positive. But let's continue to see what the remaining code is. So else, we don't put else if because there's only one condition left, and like it's a bit lengthy if you just put else if z less than 0. So we use else, print z is negative. So yeah. Okay, so now a bit confusing, but I try to explain to you. Okay, yeah. So this is called nested if statement. So it's to fulfill multiple conditions at once. So let's see here. The first block of code, we have if a condition is true. Then what's going to happen? I have another if statements be within this thing, and only then it'll put action. Okay. So I will share my screen to show you a visualization of how it works. Okay. So this website is called Python Tutor. Essentially, it just helps you to visualize the code. Okay. So let's see here. Okay, so the first line of code, we have age equals to 30. So we click next, it will go to the second line of code. And you see here, the age, the value of the variable age has a value of 30. So member equals to true. So you see here, member variable has a value boolean true. Okay, so if age more than 18, if member means that if member is equals to true, okay? So it will print the ticket price is 12. So what it's trying to do is that if the age is more than 18, it'll just go member. Then I want to try to know that if this adult is a member or not, so that they have a better pricing. So let's change the code and see what's going to happen if I make it to 15. Okay. So the age is 15. Remember, it's true. So if age is more than 18, which it does not satisfy the condition, so go to else. So if this is a member, which is a member, because member is equal to true, Then you print ticket price is 8. So what if our member, it does not have it's not a member. So let's say false. So if age is 15, member is false because the age is not more than 18, so it will be considered as a children. Then if it's a member equals to true, but it's not. So it'll go to else and you'll print the ticket price is 10. Okay. Yeah. So yeah, that's a visualization on how it works. Okay, next. So now we'll be covering the basic iterations, which essentially is just loops. So there's two kinds of loop, the for loop and the while loop. Basically what it does is that if you just repeatedly execute a block of code until a condition is met or a sequence is exhausted. So yeah. Okay, so I personally like to categorize for loops into two, which is something is that is iterable or for in range. But for in, if you recall, right, range is a function. So essentially most people think that it just follow one category. But let's see here. So I'll be going through the for I iterable first. So for iterable, if you recall, it can be a string, a list, and many more. Okay, but an integer is not iterable. Okay, so let's see the formula here. Let's see the variable x has a string value. So for I in x, which essentially means for every element or every character in the string, we we do something to it, have an action to it. So take note that there's also indentation here. Okay. So let's see the example. So for x in building blocks, the x means that for every character and every element in this string. So let's say the first element you see here is b. So for b in building blocks, you'll print b. So b here. So the next element or next character is u. So for u in building blocks, it will print u. So u. And you just print until the whole string have been iterated. So like it finished going through the entire string, then it will stop automatically. So you see here, we have building blocks as our output, but each character is output at different times, different rounds. Yeah. Okay, next. So next we have our list. So let's dive straight into the example here. So given a list called months, we have February, March, April, and June inside this list. So just to clarify, I do not have any beef with me, just that, yeah. Okay, so for I in month, so for every element in months, so our elements is February, March, April, and June. So for every element for I in month, we'll print I. So it will just iterate through every single element in this list and print the element it gets. So the first element is February, the second element is March, third is April, and the last one is June. Okay. So our next subcategory for loops is for I in range. So if you see this this formula here, for I in range, start, stop, step. So what does the start, stop, step means? Is that okay? The first variable and the last, sorry, not variable. The first argument and the last argument is the default is 1 and for step and 0 for start. but you do not need to specify. It's like optional. So, and then you just do a certain action. So let's see the example here. So for y in range 4, if we only put one variable, one integer here, is essentially just tells the computer that, hey, you should stop at 4. Okay, but we take note that this number is not inclusive. So if you see here, the first y here that is printed out is 0, because Python starts from 0. Okay, then the second one is 1, 2, and 3, but not 4, because the number 4 is not inclusive. Okay. Next, we have 1, 4. Essentially, 1, 4 means that it will start at 1 and stop at 4. So take note that 1 is inclusive, but 4 is not inclusive. So the start is inclusive, stop not inclusive. Okay. Then you print y. So let's see. The computer starts printing at 1, 2, 3, but not 4. Okay. Then our next one is for y in range 1, 4, 2. So essentially, it says that it starts at 1, it stops at 4, but it will increase 2 every time. So we see here is 1 and plus 2 is 3. So it was 3. But why not 5? Because it stops at 4. So it will never go to 4 and beyond. Okay. So the differences between for I in interval and for I in range is that the function for I in iterable, okay, is that you iterate over a sequence. So you iterate through a string, a loop, and many more. But for I in range, it will loop through a set of code for a number of times. Like it will loop through for 4 times or 3 times and so on and so forth. So the I represents the element for I in string, and the I represents the time when you should stop the range, the loop for I in range. Yeah. Okay, our next one is while loop. So what does while loop do is that it executes a set of statements as long as the condition is true. So while condition is true, it will print a certain action. Take note also that it also has an indentation. So let's see the example here. So let's say I equals to 1. So while I is less than 6. For now it's true because 1 is less than 6. So it will do the action, it will execute the action within this block of while statement. So it will print I and it will increase the counter for I. So the first thing is that while I is less than 6, you'll print I, so you'll print 1. 1 is output. Then you'll increase the value of I. So I now becomes 2. And you'll go back to this while loop again and see if the condition met. So 2 is less than 6, which is correct. And then you'll print 2. And let's fast forward to 5, okay? So assuming that I is 5, okay? So while 5 is less than 6, which is true, you'll print 5 and you'll add 6, add 1 to 6. So now I equals to 6, but this condition of I less than 6 is not met anymore. So it will stop the loop. So the loop is break. Yeah. So let's have a recap. Now we have gone through for I in iterable, for I in range, and while loops. So we have 3 functions here that can help us. So the first function is break, means that it will stop the loop when the condition is true. So let's say if something happens, then it will break. But you should try to use it for for loops instead of while loops, so that the thing is that your while loop condition is a meaningful one. Then pass is a placeholder for future code. So let's say if x equals to something, you'll pass. So it means that, for example, next time you want to code a game or a deep learning model or anything, you have a very, very long part of your codes. But for some part you want to save it for later to code. So you can use a pass so that the computer executes the remaining code you have. For the last one, we have continue. Essentially, continue and pass is a bit similar, but so it might be a little confusing. But what continue does is that it will skip the current iteration and continue with the next one. I will explain it through examples. So first, the example for break is that, let's say x equals to 0. So while something is true, your x will add to 1. So x equals to 1 now, and your print x, so it's 1. So but if x equals to 2, it will break. But 1 is not equals to 2, right? So we'll continue with the while loop and add 1. So x now become 2. So if x equals to 2, right, which is correct, which is true, so it will break the while loop. So it will stop functioning. So let's see, what if we don't add the break function here? The while loop will just keep iterate through. So, and it will give you a syntax. It will give you an error, a runtime error, because the memory is full and but the computer just keep outputting the same thing. Okay. So now we have example for continue. So let's see. So if I is equals to 3, right, it will continue, which means that it will not print the value of I. So we can see from the output here, 3 is missing from this sequence. So we know that 3 is skipped. Okay, thanks. So differences between pass and continue is that pass implies that there are no codes to execute here, and you'll continue to look through the remaining code. While continue, it forces you to move on to the next iteration of code, which is why I say that pass is a placeholder for future codes, and continue is just to ask you to skip an iteration. Yeah. Okay. Wait. Guys, are y'all catching up? I'll just make a poll here. Okay. Can y'all follow? Just a quick check. Yes. Okay. Great. Oh, someone said no. Okay. If no, then I think you should clarify in the Discord. Someone will help you. Okay. Yep. I guess we should end the poll and continue. Okay. So the next chapter that we'll continue is libraries. So like what Raina said, libraries is like a pre-written module that can provide you some functions to simplify and extend a programming task. So for example, if you are joining the Pandas workshop, Matplotlib workshop, essentially they are like libraries. Okay, next. So before you use a function from a library, right, you need to import the library, okay, to access the function. So there are a few ways to import a library. So first is simply import library. So like import the library name. So if you see from the example here, we have things like import OS, import GDOM, something like that. Then the next way is you import library as a nickname, because sometimes the library name can be too long And like, as humans, we are lazy to just type everything for every single function we import. So let's just give a nickname to it, an acronym to it. So let's say from here, we have import numpy as np. So np is, easier to code, right? Okay. So the third one, we have from library, import asterisk. So essentially, it means that from this library, right, you import everything. So we don't have an example from here, but you can see a brief example from the fifth line of code, which is like from shapely.geometry. Okay. The last one will be from library, you import a specific component. So yeah, we have example here from shapely.geometry, import point, comma, line string. So when should you use, what's the difference between just import and use the keyword from? So without the from, right, you will have to call a library function as the name of the library dot the function you want to call. But with from, right, you're able to omit the front part. Just write the function name. Okay. But take note, because you're using Google Collaboratory, right? So you don't need to install the library beforehand. But for some software, like Visual Studio Code and etc., you might need to install the library before you import. Okay. So we'll be covering two simple modules here. The first one is the random module, which essentially it helps you to generate random numbers. So the first function we have is random. So it'll generate a random float between 0 and 1. So let's see the example here. So import random, random.random. The first random is the library name, while the second random is the function name. So it will just generate a random float here, which we can see is a 0.177730 blah blah blah. Okay. Then our second function that I'm going to introduce you is randin. It's like acronym for random integer. So from the name, we know that it's just going to generate an integer for us, not a float. Okay. So we're going to have two arguments here, start and stop. So it will generate a number between the start and the stop, the custom range we have. Take note that the numbers you write in the function is inclusive. So it should generate a number from 10 to 20 inclusive. So which is correct because the computer gave us this 11, which is within the range. Okay. The last library we're going to cover today is the math module. So it's going to perform mathematical operations. So the first one, we have math.sil. So math.sil means that it's going to round up to the nearest integer. Why sil? Is because it's an acronym for ceiling, okay? Then math.floor. So it will just round down to the nearest integer. So ceiling and floor, up and down, okay? Easy to remember, right? So let's see the example here. So before we try to use the function, we need to import it, okay? So for every line of code, remember to import your library. So import math. So math.sil 0.177304, like what we generated using the random.random function. It'll just round up to 1. Even though it's 0.1, using the mathematical knowledge we have, usually it should be 0, right? But because we use math.sil, so it'll round up instead of round down. Okay, so it's 1. Then we have math.floor. So it'll round down to 0. So even you gave a number, it's like 0.99999, it'll still round down to 0 if you use the function math.floor. Okay. So the next one, we have math.pow. Essentially, pow means like power, okay? So it'll return the power of x to y. So let's see. Import math.power 2 to 3. So you'll give the answer 2 to the power of 3, which is 8. The last one we have is math.square root, which essentially it will just return the square root of x. So let's see here. Import math.square root 4. So it will give us the answer 2 because square root 4 is 2. Okay. Wait, sorry. Before we go through functions, right? Just now I forgot that we have some quick exercise for y'all to do. So if y'all can go to access the Colab file that y'all should be having right now, there is an exercise for conditionals and basic iterations. I would like y'all to use like perhaps 20 minutes. Try to attempt the exercise for basic iterations and conditionals. But I would only go through the first two questions. So the remaining questions, the answers, I will be giving you all later. Yep. So 20 minutes. Be back by 11:37 or 11:40. Okay, 11:40. Guys, please vote on the poll for our progress. Thanks. We'll start promptly at 11:40. If you cannot manage to finish the code, don't worry. You can do it after the workshop, okay? And for those that have finished coding, right, y'all can try to attempt the mini project first. Yeah. Link earn. If you have questions, right, can you drop them in the Discord? Yeah, cause y'all cannot be unmuted. So sorry. Okay, guys. We'll start explaining the codes. Okay. Let me share my screen. Okay, so the first question is that given two variables, A and B, find which variable has a longer word length. So the variable given is A, strawberry, and B equals to mango. So if you recall, because we need to find a longer word length, right, we need to use the function len, okay? So using the if statement, so because there's three conditions here. First is the length of the variable if it's more than. The second is less than, and the third one is they have the equal length. Okay. So we need to use if, else and else in this context. So the first statement is that if the length of A is more than length of B, we print A has a longer word length. Then if length is less than length B, so we need to print B has a longer word length. Else, which is the last condition, length of A is equal to length of B, need to print they have the same length. Okay, so let's see. Sorry, it's loading. Hang on a second. Yeah. So we see strawberry has a longer word length, which is correct. Okay, but let's what if we try let's say fake. Okay, if you run, mango has a longer word length. Okay, so it's correct. Take note that for Python, right, when you put, let's say if length a equals to 3, if you click enter, you do not need to type in another tab or another space. Okay, they'll automatically indent for you. Okay. Yeah. So the second question for conditionals is given a variable A, strawberry, print in list if the variable is in the list. Else, print not in list. So we have the list here, fruit list is orange, apple, mango, and grapes. So my solution would be if A is in fruit list, means that if the variable A, which is strawberry, is inside the fruit list, so it will print in list. So it means that it will compare. So it will say, is strawberry equals to orange? No, next variable. Is strawberry equals to apple? No, next variable. Mango, and so on and so forth. So it should print not in list. Okay. Because there's two conditions here, only either is in list or not in list, so we only use if and else. Okay. But we can also change, and we can see how. So let's say A is mango, right? It will print in list. Okay. That's the first two questions for conditionals. So far, so good. Okay. If you have any questions, can just type in the Discord channel. Okay. No worries. These answers for the third and fourth question will be sent to you later. So we have our next two questions for basic iterations. The first one is given a list of fruits, print out the name of the fruit if the word length is less than 6. So for this, we need to use for loop because we need to iterate through every single element inside the list. And we also need to find the length. So it's like an upgrade from our previous question. Okay. So given the same fruit list, so for I in fruit list, for every element in the fruit list, if the length of the element, length I, is less than 6, you print I. take note, you must include this colon, or else you'll give you a syntax error. Okay, so let's see. You just print apple and mango. But let's say we try, okay, let's say we want less than 7. So you print orange, apple, mango, grapes. Okay, let's just change back. Okay, so our second question is that given variable A, apple, find the third letter of the variable and print it out. So for here, my solution is that I'll be using for I in range. But of course, there's a lot of, in the coding world, one thing that's very interesting is that you can use different approaches to give the same solution. So of course, you can try out different solution. As long as it prints P for you, then it's fine. Okay, but I'll explain my solution to you. So for I in range, length of A, which is 5, take note that this must always be an integer. Okay, so length of A. So if I equals to 2, why must it be 2? Because we are finding a third letter, and in the Python world, everything starts from 0. So 0, 1, 2. Okay, so print print the character of A, which is apple, that has the index of 2. Okay, so you see, if you print P. So what if we change to, let's say 0, it will print A. Okay, so this is indexing. Then let's consider this condition. Why is this solution not workable? Okay, so for I in A, so for every character in inside this string, which is okay, maybe makes sense. So if the index I is 2, okay, so it'll print I. So why is it not workable? If you see, it prints out nothing for us. But if we change the thing, it'll print 2 P's. Why is it so? It's because, right, for it, because this index function, it only traces the first letter it can find. So let's say for P, which is the third character in A, P. So inside this thing, right, if it's 1, P is always, the index has always a 1 here. So because index can only find the first, the first element, this function can only find the first place where the character can be found. Okay, so it's not workable when you have something like apple, when there's 2 same alphabet inside this string. Okay, but if you change it to, let's say A equals to orange, right, it will work. Okay, so let's see. Oh wait, sorry. See, small errors happen. We should make it a string. Okay, which is correct because it's A. The A is the third letter. Okay, so yeah, that's it for the explanation. And now I'll hand time back to Reina.
Okay, so now we're going through functions, which are really useful. So firstly, what is a function? So it's a reasonable bit of code that's predefined. So it may require values known as arguments to be passed into it, and it allows you to break down your code into readable bits. So here's an example of a function that you define, but stuff such as your len function, your max function for lists, those are all considered pre-built functions. So they are included in Python itself. But let's say you want to create your own one, then you can do it like this. So here's the declaration of a function. So the main keyword for declaring a function is this def keyword, so def. Then you put in your function name and your parentheses. Within your parentheses, you can specify different types of arguments known as parameters. So here we have one called args and we have another one called kargs. And underneath we have the code. So you need to take note of the indentation. So it signals to Python that, hey, this code is under this function. Yeah. So there are two types of parameters. So as you saw before, there's args and there's kargs. So kargs is short for keyword arguments. So arguments are basically mandatory. So you need to pass something in to fulfill the argument, then the function will run. Otherwise, keywords are optional, so they have a default value if they're not indicated. So if you look at the example on the right, load image, this is from a game development project. So we have argument, a normal argument path. Then we have two keywords, color key and alpha. So what this means is that in order for me to run this function load image, I need to at least put in a value for path. These two I can specify if I want to, but otherwise there's a default value and I do not need to pass something in. Yep. So returning values, it's basically how a function can be useful for you. So it basically tells your main block of code what's it's like status update. So it may return useful information back to the main code by returning a value. Use the return keyword. So in this case, is example of checking whether a number is even or not. So we have num mod 2 equals to 0. It will return true because the number is even. Otherwise, it will return false because the number is not even. So moving on to the mini projects, Zheng will go through the ones that she implements.
Yeah, so technically that's the end of our content teaching. So now you all will be trying out some mini projects. So you all can find the detailed explanation in the Colab file under mini projects. So if you go to the table of contents, go to the mini project section, you can find them there. So the first project is that you should calculate when's the leap year. Okay, so if we recall, the leap year occurs in every year that is evenly divisible by 4. So unless the year is evenly divisible by 100, in which case it's only a leap year if the year is also evenly divisible by 400. Okay, that's the introduction for leap year calculating. Then the second project is a bit is for intermediate. Okay, so you need to create an NRIC validator. So let me explain how it works. Okay, so let's say this is your NRIC. Okay, S1234567D. So the prefix, which is the S, it can be S or T. So if you're born in the 19, like 191999 or 1970 or anything else, your prefix should be S. But if you're born in the 20, it's T. If you're ever curious why is it like that, it's because S and T is the 19th and 20th letter of the alphabet. So yeah. Then the numbers in between is the check digits. It is used to check for the last letter. Okay. And the last letter is the validating factor, is to ensure that the NRIC is valid. So next, we have this algorithm that is prepared for you, found in an article. Okay, so you can go to the Colab file to find the article to have a better reading on it. But the steps are summarized as follow. So first, right, you need to multiply each digit. So it's the 1 to 7 in NRIC numbers, but its weight. For example, which is 2, 7, 6, 5, 4, 3, 2 in order. So let's say your first number is 1, so you need to multiply 1 by 2. The second number is 2, so you need to multiply 2 by 7, so on and so forth. Okay. Then you need to add together the above products. So you need to add everything together. And if the first letter, which is the first letter of NRIC, starts with T, you need to add 4 to the total. And you need to find the remainder of the sum calculated above, which using mod 11. Okay. And if so, using the remainder, right, you can find whether the last digit, the valid last digit. So in the case of our previous example, the remainder is 7, so the last digit should be D. Yep.
Now moving on to the advanced task, which is implementing a version of tic-tac-toe into your game. So there's an additional criteria of using the random module to sort of create a form of artificial intelligence to play with the user. So while the task may seem simple, you will have to implement the different steps into tic-tac-toe manually, programming it. So it's actually a bit harder than it looks. So you have to find a way to print out the grid, store grid information, take user input, and modify the grid as needed. And you have to also check for any draws or whether someone has won. So it's highly recommended that you use functions to segment and organize your code. Otherwise, it will be really long and really unreadable. So have fun with this. So it's basically the end of our workshop, but we will give you some time to work through the projects first, roughly 30 minutes until 12:30 for you to mess around with the projects before we actually summarize what we've learned today and ask you to do a feedback form. So if you have any questions, do remember to post them into the Discord channel for us to answer. Yeah. Oh, and I forgot to mention the answers for the exercises and the mini projects will actually be provided to you at the end of the workshop. So if you do want to review and if you have any other further questions, like after seeing the solutions, you can ask to help like bolster your understanding. Yes. Hi guys. You guys can return to the Google Meet, and then we'll be having like really short explanations as to how we will implement the code for the different mini projects.
Okay, so for the first mini project, right, it's about leap year. So as you can see, we are trying to get a user input here. Yeah, okay. We're trying to get a user input here. But what does this int function do here is that because the default type for input is string, so we're trying to convert a string to an integer. Okay, so if the integer mod 4 is 0, means that it's divisible by 4, and it's and when and the year is when it's not divisible by 100 or divisible by 400, the thing is a leap year. Okay, else it's just print it's not a leap year. So we can try out and we can see let's say 2022 is not a leap year, which is correct. And we can see it's 200, it is a leap year. Okay, so yeah, this is a very, very simple project. Okay, right? Okay, we'll proceed then to the NRIC validator. So the first line of code essentially is that we are trying to ask for the user input for the NRIC. So why can't we, why do we not have the int function before this input function? It's because the NRIC consists of S and D, which are letters. So like we should not, it cannot be transformed into an integer. Okay, so this function here is trying to make everything uppercase. So dot upper means that it will change every letters from lowercase to uppercase, so that even if when the user type a small letter s or small letter t, the function, the Python code here still works. Okay. So here we define a function called NRIC validator, which takes in an argument of NRIC. So we first initialize the variable. So total is equal to 0. The weight for each digit is 2765432 stored in the list. And our last character should be JZIHGFEDCBA according to the indexing, because if you recall, our if the remainder is 0, the last digit should be J, and if our remainder is 1, the last letter should be Z, so on and so forth. So here we're trying to obtain the numbers in NRIC so that we don't need to type everything out for multiple times. So digits is equal to NRIC, and we're trying to slice the string here. So it's 1 to 8. Note that 1 is inclusive and note that both is inclusive. So it should give you the first character, the second character until the 8th character. So here we are trying to implement a first step and a second step from the algorithm. If you recall, we're trying to multiply and add them together. So let's see here. For I in range, length of digit, which essentially it should be 7. So total plus equals to the digits, the first, okay, wait. Let me just put in everything to the Python visualizer for y'all to visualize everything. Give me a second. Okay, you can see the Python visualizer, right? Okay, yeah. So let's visualize execution. So you see, the first thing is it will ask for input. So let's say our input is S1, 2, 3, 4, 5, 6, 7, D. Submit. So our NRIC will become upper. So it will just go into the first. So if our length of NRIC is equal to 9, because we need to check that we have the correct length, or else it will just be invalid. So it's correct, so it will proceed to the next one. So if the NRIC input 0, the first letter is S, or the first letter is T, which is correct, condition fulfilled. So it will print NRIC validator bracket NRIC input. So essentially, it will just call out this function NRIC validator. So you'll see here, the code will run back to this defined function here. So we initialize the total, weight, last character, and we obtain the digits, which is 1, 2, 3, 4, 5, 6, 7, which is correct. Then for I in range, length digits. So let's say I is equal to 0. The total will be the first character of digits multiplied by the first element of weight. So let's see here, is 2. Because digit, which is 1, times the weight 2 gives us 2. Take note that there's an integer we need to transform digits to integer because the digits here is a string. String cannot be multiplied by a weight. So it'll be 16. It'll just continue until I reaches 6. So say I reaches 6. Then our remainder is the total mod 11, which is equivalent to the step 4 in the algorithm. Notice that step 3 in the algorithm is skipped because the first character of NRIC is not equals to T, is S. So remainder is 7. And the actual NRIC will be the NRIC input. This is this is a string slicing because we're trying to obtain the first character until the second last character of our our user input, because we are not sure about whether the last digit is correct. So this actual represents the valid NRIC despite knowing the user NRIC, because we're trying to validate whether it's correct, right? So if actual equals to NRIC input, then it should return NRIC is valid. So else it will just return NRIC is invalid. So if it will return, so it will print the thing it returned. So you might be confused, why is it return, not print? It's because when a function is returned, right, means that it's trying to it means that this code here is equals to NRIC is valid, is valid, sorry. So it will print out this thing. And yeah, it prints out this. So what if, right? Oops, sorry. Okay, let's re-execute it. So let's say our thing is just S1, 2, 3, 4. What we do is that it will check if the length is correct, but in this case it's incorrect, so you just print your input length must be 9. Yeah. That's all for task 2. Now Rainer will be covering task 3.
So tic-tac-toe, this is the way I would implement it. It's a bit long, it's 142 lines, But if we scroll down to if name equals to main, because that's how I prefer to segment code. There's the functions on top and the main code at the bottom. So you'll see that I predefined the grid to be a matrix. In this case, a 2D matrix with each list containing 3 elements of -10. So why I put -10 is so that it's easier for me to calculate whether there is a winner or whether it's a draw. Then I have that written down in the notes that I assign the value of 0 to circle and 1 to cross. Then after that, I have the list of available places. So I arranged it so it looks like a matrix, but it actually isn't. So it's more readable. And after that, I said that winner is an empty string. After that, I ask the user for an input. So I use a while true loop so that if the user doesn't input a valid choice, right, then it will just keep on asking him for a valid choice until it is considered valid. So in this case, the user has to choose 1 for cross or 0 for circle. So if it isn't 0 or 1, it will print invalid input and loop again. So if the player chose circle, we will print out the grid, then ask the robot to make a choice, because for the way I implemented it, cross always goes first. Yeah. Then while we do not have a winner, that's why it's an empty string, because empty strings are implicitly converted to false. So while not false, we'll evaluate to while true. If there are, then the next line checks whether there are any available places. If there are no more available places, they will run the code in the if statement and check whether there's a winner. If there is no winner and there are no available places, it's a draw. So it prints out a draw and breaks out from the while loop. So after we print the grid and we provide the user with their available choices. So this whole for loop for place in available places basically prints out the different choices the user has. So you may want to read through this on your own time to better understand how this is implemented. Then after that, there is the user input for where they want to place the circle or cross in the while true loop. So it's the same principle as the player choosing whether they are playing cross or circle. So it forces them to make a valid choice. Otherwise, they can't escape from the loop. Then we modify the grid where we add the player's choice to the grid. After that, if we check whether there's a draw again, then after that we ask the robot to make that turn and check for winner. Yes. Then if you scroll up, you can read through the different functions, the way I implemented them. So firstly, we have the modify grid. So it's very simple. We just have the arguments asking for the grid, the different available places, the position that we want to modify, and the player ID. So whether they're playing circle or a cross. Then we modify the grid into the ID. So we place the circle or cross at a position. Then we have the available places. We remove the location that we use because it's no longer available. So we remove it from the list of available places. And after that, the function below is for printing out the grid. It's a bit hard to explain now because it's a nested for loop. But if you look through it and you iterate through every line of the for loop, it should be a lot easier to understand. And after that, we have the role, where we have the robot choose an available place. So we use the random.choice function We use the random.choice function so that it can randomly choose an available place for it to use. Yes. Then we modify the grid. And after that, we check the winner. So for checking the winner, we split them into 3 cases. So we have the horizontal, where we have horizontal with three of the same like circle across. Then we have the vertical, and then we have the diagonal. So if you remember the different values I assigned for cross and circles, right? So we have cross is equals to 1 and circles is equal to 0. So if in one row, one straight row, we have them all be crosses, then we have 1, 1, 1, 1, 1, 1. Yes. Then the sum of that row value will be 3. But if we have circle, 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 it will be 0. So we can use that trick to determine whether we have a winner or not. Same thing with the columns, where we add up the column values and see whether it's equal to 3 or 0. If it isn't, that means there is no winner. Then we have the diagonals, where we manually calculate the diagonals. Wait, sorry, can you scroll down? Yep. So we have the column sums, where we add the column values. Then we iterate over the column sums to check whether that we have a winner or not. Then we have the diagonals, where you just manually compute each diagonal, because there's only 2 diagonals, so it's not too difficult. And we check manually using the if statements. If there are no winners, then we just return an empty string, because that's how we implemented it at the start. Hopefully that didn't confuse you too much. Since this implementation is mostly using what you have learned from our workshop. Okay. Moving on to the main slides. So we have technically come to the end of our workshop today. However, we still have some stuff to say. So here's a summary of what we've covered. So we've covered the different variables and data types. So we have integer, float, string, list, and dictionary. Gone through functions. And Justin has gone through the conditionals. So we have the comparison operators, if, elif, and else statements, for and while loops, and importing libraries. So you basically learn the basics, but of course practice makes perfect, especially for programming. So you should have a good foundation here to do your own projects, your own practice. And if you do wish to dive further into data analytics, just attend the other workshops to learn more about the different libraries in Python for data analytics. So here are some other resources of further readings if you want to know more about like the nuances of Python. They should be in the exercise notebook, Colab notebook for you to use. So here's a feedback QR and solution QR for you to scan and do. I'm just gonna stay on here until 1-ish for you to do. Once you're done with the QRs, then you can leave. But if you have any further questions, do remember to post them into the Discord channel. Answers will be provided in the March Workshop Resources Discord channel.
Yeah, it's there already.
Yeah. Okay.
Find them. But
So you can
please,
find it under Intro to Python resources.
yeah, please complete the feedback QR. Thank you. Before you leave, yeah. After you are done, you are free to leave. Thank you.